So today we are going to learn about how to do atmospheric correction using FLAASH. So we need for doing FLAASH atmospheric correction, initially we do need to convert our image into radiometrically corrected image, because we need radiance image for our input for doing FLAASH atmospheric correction. So just type here radiometric uh, calibration. So double click here and select the image you need. Okay, click OK, and then don't forget to click apply flash, because we need output interlevel as bill and data type as slot. So if you click here, uh, it will change. See, you see the radiance and bill, it is for float type, but it was initially it was different. So I'm repeating that you need to click on apply flash setting, otherwise it will not work for flash atmospheric correction. So let's save it video. Okay, it's better to select that folder first. So desktop. Okay, video. So save it and click OK. So it will take a little bit time to carry the analysis. So sometimes it takes more time than usual, but it will be done within few minutes. So sometimes you can see that if software is not working well, it will say it's not respond, but eventually it will work. So let's wait. So meanwhile I can repeat that. So we need radiance and bill format for doing atmospheric correction. That's why we are doing radiometric correction before doing flash atmospheric correction. So analysis doing inside. That's why we have to wait few more minutes. So and we can also do some other atmospheric correction. In our next lecture, I will discuss about the quake atmospheric correction, but now we're just doing our flash atmospheric correction. Today it's taking more time than usual. It does not take that much time usually. Maybe my computer is working very slow. But it's working. I can see here. So if any change internally occurs, you can see in the bottom of right corner. So if anybody wants to do some more analysis or get more information about atmospheric correction, you can read the official page of ENVI software. Actually, ENVI offers more than 4 types of atmospheric correction, including thermal, and these 2 types of that I have mentioned, flash and quake. So based on your need, you need to do different types of atmospheric correction. Okay, so finally it's done. It took more than 2 minutes, but usually it takes only 10 to 30 seconds only to do this calibration. Of course, it depends on the software capacity and how your machine works on their software. Okay, we are now ready to move on FLAASH. So you just need to type here FLAAS and then click here. So you see, as I mentioned earlier, we need to have the input of radiance image. That's why. So the first one I need to select. So use single scale factor for all bands, and then you just need to select your output file location. So say I want to save here. So I do the FLAASH atmospheric directions and name it FLAASH. So then you need to define your directory. So I'm doing defining the same thing. Next, this file new folder. So that means you need to define your reflectance file destination and then output directory, and then you can put root name here. Just put so some here, whatever you want, it doesn't matter. Okay, then based on your image, ENVI software can automatically upload something from here. So you see, and that latitude and longitude already open, but you need to select sensor type to get exact information that is necessary for this analysis. So my image is multi-spectral image, so that's why it's Landsat A. I have selected this one. So you see, we have a lot of information getting from the image automatically by ENVI software. So actually this is an image of Bangladesh. So that is actually a city area. That's why we need to select our atmospheric model as so it's in a tropical area. So you see that based on your country and location, you need to select the different options available. As Bangladesh is a tropical season, so I have selected tropical. And for aerosol model, we have rural, maritime, urban, atmospheric. So this, as I said earlier, this image is on a city area. So I just selected urban, and then so we don't need to select other options here. And for ground elevation, maybe you need to put your ground elevation for my image. So that city is located 27 meter above the main sea level, so I think it should be 27, because you need to put your value in kilometer. So I calculated 27 meter into kilometer. Okay, so you have a lot of options, say band, water view, caravan view, but based on your requirement you can select and change the setting here. If you select the over water, then it will give different options, but for me I am not selecting anyone. Aerosol retrieval is none. And then next you need to select your advanced FLAASH settings, where you can define your required options. See, if you select none, then your option is automatically fill up, but if you select any options here, say this one, then when you go for advanced, then you have different options. So, and then I have selected none, so clicks on apply, so it starts working. So only 1% is done. I believe it will take more time because this time my software is working a little slow. So my suggestion is to, before doing your atmospheric correction using FLAASH, just you need to uh, know about the options available here, which option is needed for which one. Say, why do you need to set your atmospheric correction model, which area that is located, and then your aerosol model as well based on the location of the image. And then well, I think it's the default 40 is fine, but if you define your aerosol retrieval, then you need to define this. One more thing, you can change your water retrieval. So if you click yes, they will show you more options. That means everything depends on how you want to do your atmospheric correction. You need to do a little bit more. So now in ENVI, there are some interesting fact that most of the information you could have put manually, but this software can automatically grab based on the metadata embedded in that image. So while watching this video, um, you can move forward if it takes more time to get the uh, final image, because I have to wait to show you how it works. And then if you want, you can move forward to see the end points of the analysis. So till waiting for the last image, we can discuss more about atmospheric correction. Why do we need this atmospheric correction? So for your perfect analysis, usually people do the atmospheric correction based on their requirement, because we all, if you have some remote sensing background, then you will know that so the sensor captured the image from the above of the earth surface. So it has some particles, uh, water vapor in atmosphere that um, disturb capturing the image perfectly. And then we have clouds in our image and some other factors that influence on the quality of that image. That's why when we do atmospheric correction, all those factors that negatively impact on our image get changed. So that's why we need to do atmospheric correction. So I believe who is watching this video definitely know those basics. Oh, finally it's done. So it took uh, more time than usual. So I thought it shouldn't take that much time. It's still 68%, but finally it will. It's forwarding. Yeah. So people who just waited till now, I suggest that you can move forward to watch till end. Okay. So then once you are done, you will get your message that you have already done your atmospheric correction and some other relevant information where you can get your output file, template file, visibility, so etc. Okay, now let's get our image uploaded. Mm, let's try this one. Atmospheric correction. Okay, so finally this is our image. You can see it's much better. So toggle on, then this is radiometrically calibrated, and this is the initial image. So now you can see the difference after doing the atmospheric correction. It's much more better and more visible. So, and if you scroll, zoom out, you can see more about details of each structure. So based on my experience of images, we can say that uh, and this is urban area. So you know this is water, this is water, and this is forest area. Okay, thank you for watching. See you next time in next video.